Here for example 2, the easiest way to graph a couple functions, you're going to sketch them. You're not going to use your graphing calculator like some of you guys like to try to do all the time. So it says you have to sketch a graph. Whenever it says sketch, that means you actually have to make a table of values, and you need to plug in, you need to make the table. And so on your homework from now on, you guys need to be showing your tables and not just plug them into a calculator, because then that's just not going to work. Yeah, no. Alright, so what we're going to do is we're going to plug in x values. Now for your exponent, it doesn't matter what numbers you plug in. I'm just going to plug in -2, -1, 0, 1, and 2. And when you evaluate these, you get a 3 to -2. Well, 3 to the -2, if you remember anything about exponents, that just means you get a 1 over 3, and then you square that. So you get a 1 over 9. So what we're going to do is you're going to go back 2 and up 1/9, which is, okay, that's real close. It's real close to a 9th. Same thing with 3 to -1. That just flips that over and makes us a 1/3 to the first power, which is just 1/3. So you go back 1 and you go up 1/3. So that's, it's 1/3. Could be closer to 2/5, but I think that'll work. Plug a 0 in. Now, anytime you get anything to the power of 0, that is just equal to 1. So we have an ordered or a point right here. Plugging a 3 to the first power gives you a 3. Putting a 3 squared gives you a 9. So we're going to go to the right 1 up 3, to the right 2 up 9. 3, 6, 7, 8, 9, somewhere up here. So then you draw on this line. If you notice, when you draw on this graph, as it goes up and up and up and up, you're going to hit that point. As you go to the left, it doesn't cross your x-axis. It just keeps going along here to the left. So you get that point right there. So that is your function, f of x. And if you're graphing these on the same function, you need to live which one's which. So let's do b here, where we have g of x, and we're going to make a table. And you're going to have an x, a y, and let's just use the same x and y values. We're going to say -2, or not y values, but same x values. Let's plug these in. So you're going to get a 5 to the -2, which is a 1 over 5 squared, which is a 1 over 25. So that's going to be back 2 up 1/25. That's going to be right below the blue line. Plug a -1 in, so you get 5 to -1. That is a 1/5. So that's like a 0.2. So back 1 up 0.2. It's going to be right below your 0.33. Plug in a 0, 5 to the 0. Anything to the 0 power is just 1. So you go 0, 1. Here they have a common point. Plug in a 1, you get a 5. So we say over 1 up 5 is right here. And then plug in a 2, you're going to get a 25, which is not going to be on our graph. So if you plot these points, notice your red graph is below your blue one, and then it goes up. Actually intersects your blue graph. Comes down through here like this. Keeps going up. And as you go to the left, it's going to be along your x-axis, but it's not going to touch it. So when you look at these two graphs, you can tell a couple different things. If your a value gets bigger, that graph follows along your x-axis for a long time, a little bit longer, and then it has a sharper curve going up. Well, if your a gets smaller, then you have a wider curve. You still intersect through the same point though. Both graphs actually have the same asymptote. They both have a horizontal asymptote at y equals 0. And the only time that asymptote would change is if you have some number. So you get h of x equals maybe 5 to the power of x, and then maybe you have a -1 out here. That would shift this asymptote down 1, or you could shift it up 1. but otherwise they're all going to intersect at the same point 0, 1. So hopefully you can look at these two graphs, maybe find a couple other comparisons and similarities, and you can share those with your lovely classmates, because more likely they probably didn't watch this video anyway.